All right, today we are diving deep into the engine room of Merg-E. Now, this is a language built from the ground up for the really intense, massively parallel world of Web 3.0. And we're going to look at its secret weapon, this super unique scheduler inspired by Norse mythology that's designed to juggle thousands of tasks at once. Let's get into it. So, here's the game plan. First, we'll look at the big puzzle that Merg-E's trying to solve. Then we'll meet the mythological heart of the system, follow a task on its journey, and unpack this core idea of giving hints, not commands. And finally, we'll see what happens when the whole system goes into panic mode. Okay, so let's set the stage. Modern systems, and I mean especially in the Web3 space, are just getting slammed with concurrent operations. I mean thousands of things happening at once. And the real trick is, how do you manage all that without the whole thing just falling apart? So this is the million-dollar question, right? How do you build a system that can handle massive parallelism, but is also tough and resilient? A system where you have no idea if you'll have 10 threads or 1,000 threads available from one second to the next. Well, Merg-E's philosophy is kind of different. Instead of you, the programmer, shouting direct orders, you just give gentle hints about what you're trying to do. You hint at how you want things to run in parallel. And then this really smart runtime takes those hints and figures out the best way to make it happen, adapting to whatever's going on at that exact moment. And this is where it gets really, really cool. At the very core of the Merg-E runtime, you've got two components with names pulled straight out of Norse mythology, Níðhöggr and Yggdrasil. Okay, first up, Yggdrasil. In the myths, it's the world tree that connects everything. In Merg-E, it's not just some simple to-do list for tasks, no way. Think of it as a massive living database in memory. It's structured as a directed acyclic graph, a DAG, which is a fancy way of saying it understands not just what the tasks are, but how they're all interconnected and dependent on each other. It holds the entire universe of work. And then you have Níðhöggr. In mythology, this is the dragon or serpent that's always gnawing at the roots of Yggdrasil. And in Merg-E, it's pretty much the same idea. It's the scheduler, this relentless dispatcher that is constantly digging into the Yggdrasil database, figuring out what's what, and deciding what task gets to run next. So here's the absolute key takeaway. Yggdrasil is the what. It's the map of all the work that could be done. Níðhöggr is the how. It's the active brain, the decision maker, that looks at the map and decides which task runs on which worker and at what exact moment. So with this giant world tree of tasks and a dragon scheduler, how does a single little task actually move through the system? Well, to make sense of all that chaos, Yggdrasil is split into 4 conceptual zones. It's like a roadmap for the life of every task. Every task starts its journey in the new zone. Níðhöggr grabs it, takes a look, and decides where it goes next. If the task is waiting for something, like a network request to finish or a lock to become free, it gets moved to the unfulfilled zone. If it's good to go right now, it jumps straight to ready. As soon as a condition is met for an unfulfilled task, boom, it gets promoted to ready. Then, once Níðhöggr runs a task, its result pops into the done zone, which is a signal for Níðhöggr to look at everything all over again, maybe promoting even more tasks. It's this continuous reactive loop. And this brings us right back to that core idea. If Níðhöggr is making all these decisions on its own, how do you, the programmer, have any say at all? Well, you do it with hints. You're not the boss, you're more like a helpful navigator. Here's a perfect example. You can create something called an actor. This is your hint to the scheduler that, hey, this thing is going to be around for a while, and it has some state I care about. Níðhöggr gets that hint and makes the actor sticky. It tries its best to schedule it on the exact same worker thread every single time. That's a huge performance win, right? Because the CPU cache stays hot. On the flip side, a regular function is treated as disposable. Níðhöggr can throw it onto any worker that has a free moment, just to get it done as fast as possible. And you can get even more granular with these things called actor sitos. Think of them as teeny tiny microscopic functions. They're the basic building blocks for your loops and if statements. And here's the crucial part. Every single actor sito is a chance for the scheduler to interrupt. It's a preemption point. It gives Níðhöggr a chance to pause what it's doing and maybe run something more important. So even a super tight loop won't ever freeze the whole system. Now this next part is a bit of a mind bender, so stick with me. This quote says it all. Merg-E completely redefines what a lock is. It's not this big, heavy stop sign that brings a whole thread to a screeching halt. No, A lock is just another hint. It's you telling Níðhöggr, hey, this task I just gave you has a new dependency. Just put it over in the unfulfilled zone for a bit, and I'll let you know when it's ready. The worker thread doesn't wait. It's immediately free to go do something else useful. So the system is clever, it's flexible. But what happens when you've got a really high priority, this has to finish right now kind of situation, and it's stuck behind one of these conditional locks? Well, that's when the scheduler needs to go into a high-stakes mode. So let's just lay out the problem. You've told the scheduler, only run this piece of code when this file is available. Okay, great. But what if, inside that protected code, you now have to await a response from a server? That's a huge problem, because now you're holding up a really important resource while you're waiting for something totally different. Merg's solution for this is called the hazardous blocker. Normally, you can't await inside a lock. It's forbidden. But if you mark your awaitable as hazardous, you're basically sending up a flare. You're telling the scheduler, I know this looks bad and it is risky, but I absolutely have to do this. It's an explicit signal that a critical resource is being held hostage by an async operation. And this quote right here, it gets straight to the point. That hazardous keyword isn't just some note for the compiler. It is a direct, screaming alert to Níðhöggr. The second it sees an await on a hazardous blocker, it flips a switch. The scheduler goes into panic mode. So what is panic mode? It means Níðhöggr throws its usual rules about fairness right out the window. Its only goal, its entire reason for being at that moment, is to resolve that hazardous blocker and get that lock released. It will aggressively prioritize anything and everything related to that blocker, even if it means other less critical tasks get completely ignored. It will cut corners, it'll do whatever it takes. It's powerful for sure, but you can see why they call it hazardous. So let's wrap up with this thought. A system like Merg-E really forces you to change your entire mindset. You're no longer the micromanager of threads and locks. You're more like an architect, describing the shape of the work to be done, and then trusting this incredibly sophisticated scheduler to execute your blueprint. So how does that change the way you'd approach building a really complex parallel system? It's a fascinating question, and it's really at the heart of what makes Merg-E so different.